At lesson 17, optimization. What's fantastic here is this literally is the last lesson of our calculus booklet. We'll be looking at a bit of an overview of calculus as well, which should hopefully be useful just to bring all these ideas together. So optimization, we've already looked at optimization previously in a fair bit of detail, so we've probably seen some of the harder questions already. What this lesson's about is just a bit of a recap on how it works. Okay, so optimization, you want to optimize something. Usually it's maximizing the volume of a box or minimizing the cost of a product. And so typically you're going to use calculus to find stationary points. Usually they are minimums or maximums. So that's what it means by maximizing or minimizing. It's the umbrella term. The umbrella term for all those is optimizing. Okay, so making something the best. Okay, so let's have a look at this one problem. We have the area of a rectangle was to be 50 centimeters squared. Find the dimension of the rectangle if its perimeter is to be a minimum. Okay, so let's unpack this a bit. Firstly, we've got a rectangle, so we could draw a pretty picture of a rectangle. We know the area is going to be 50 centimeters squared. We haven't been given any dimensions, but we could say that this is the width and this is the length. Okay, and we've got an equation, area is equal to length times width, and we can sub in the area being 50. And here we have equation 1. Okay, so the area of this rectangle is 50. So find the dimension of the rectangle if its perimeter is to be minimum. So we're trying to minimize the perimeter. So therefore we want to get an equation for the perimeter. So what's going to be the perimeter equation here? We've got 2w's plus 2 lengths. Hopefully you remember how to find a perimeter of a rectangle. The next thing to minimize is that we can see that for this equation 2, we've got width and length, 2 variables. At the moment we don't know how to differentiate with 2 variables, so we need to swap out one of the variables. So equation 1 is the thing to do that with. You can either swap out L or you can swap out W. It doesn't really, but you could also equally choose W. The reason for that is they're both equal. It's like a symmetrical thing. Sometimes one is way easier to rearrange into than the other. So just look out for that. Okay, so we've got equation 3. Now let's sub equation 3 into equation 2. Let's see what we get. As always, I'm going to bring up the W to make it a negative indice, just so it's on the numerator. Now let's differentiate in terms of W. There we go. Now we want to find a stationary point. So how about we make that dP by dW 0, because we know it's going to have a gradient of 0. Okay. Now we want to get W by itself. With all this, if you have to solve, I recommend just writing the variable out as a positive index. If you ever have to solve it, it just makes life way easier. Now, what was our trick to get rid of that W squared? What's the denominator? We times them all by W squared. It's a disguised quadratic. Now we know how to solve that. So let's bring 100 to the other side. Then divide by 2. Then take a square root. And I'm just going to swap this at the same time as I do that. Now I'm going to put in plus or minus just for practice, but I know that one of these answers is not sensible. So we are going to accept the root 50, but we're not going to accept the negative root 50 because a negative width doesn't make any sense. Okay, so now we found our width is going to be root 50. What you could do is you could simplify that. We know 25 goes into that. So it becomes 5 root 2. It's always nice to simplify these if you can. Centimeters. So what's the length going to be? All right, well, we can put it in. So we've got the width. Let's find the length. Okay, now our equation 3 was length is equal to 50 on W. So let's use that. And let's rationalize the denominator. And we get 10 root 2 on 2, which becomes 5 root 2 as well. Okay, now in true calculus spirit, they just want to basically make it a square. So we can see here that the length is going to be 5 root 2. Okay. So overall, seems like we found our answer there. It says find the dimensions of the rectangle. One thing that's probably safe is just to make a statement at the very end, just summing up everything you've found. So I'd recommend going, therefore the rectangle is, was it 5, or let me clean that up, 5 root 2 by 5 root 2 centimeter object. And you can even say we want to minimize the perimeter. So we could use that rule if you want, where we plug it in 2w plus 2, length. And that pops 10 root 2 plus 10 root 2, 20 root 2 centimeters is the minimum perimeter. Okay, so there we go. We've been through this example here. We've minimized. We had a negative indice there, but that's absolutely fine. We have some surds to deal with, a bit of calculus. There's so much stuff that's all coming together in this example. That's why I really like it. And yeah, I hope you found this video useful. Basically what we'll be doing is just doing a recap of everything we've covered and really just trying to simmer down everything that we've learnt. And yeah. Thank you. So I hope you found this video useful, and yeah, thank you.